Welcome to the public exam review for Chapter 8 on logarithmic functions. In this presentation, we will use some applications involving exponential growth and decay and use our knowledge of logarithmic functions to solve these equations. Here we will focus on solving an exponential equation in which the bases are not powers of one another. We will solve a problem that involves exponential growth or decay, and solving a problem that involves the application of exponential equations to loans, mortgages, and investments, and solving problems used by modeling a situation with an exponential or logarithmic equation. We have 4 examples that we will use, and we will also apply these properties of logarithms as we solve each of the following situations. So we have the product law of logarithms, where the log of a product is equal to the sum of 2 logs. The log of a quotient is equal to the difference of 2 logs. The power law of logarithms, where the log of m raised to the power of p is equal to p multiplied by the log of m, maintaining a base of c throughout. As well, if the log of L is equal to the log of R with the same base of C, then we can conclude that L is equal to R. If we have L equal to R, then we can take the log of both sides of that equation so that the log of L to base C is equal to the log of R to base C. Let's look at the first example. Here the population of seals increases at a rate of 12% every 2 years. How long will it take a population of 7.4 million seals to reach 10 million? So what we have in this situation is an exponential equation, or we could form an exponential equation of the form y equals a multiplied by c raised to the power of x over b. We know that the initial population of seals gives us the value of a to equal 7.4 million. The value of c. In this example, the value of, we're told here that the population of seals increases at a rate of 12%. So this is an example of exponential growth. So the value of c is determined by 1 plus the rate. So we have c is equal to 1 plus 12%. Changing 12% to a decimal, we have 1 plus decimal 12, so that the value of c is equal to 1.12. And since the population increases at a rate of 12% every 2 years, we know that the value of b is equal to 2 years. So now this equation can be represented as follows. We can say that y is equal to 7.4 multiplied by 1.12 raised to the power of x over 2. And what the question is asking us to find is it says here, how long will it take a population of 7.4 million seals to reach 10 million? So really what the question is asking us to do here is to find the value of x when y is equal to 10 million. So we want to find x, which represents the time, when y is equal to 10 million. So let's substitute in these values into the equation. So we have y is equal to 10 equals 7.4 times 1.12 raised to the power of x over 2. Now we need to solve the equation, and we can begin by dividing both sides of the equation by 7.4. We're trying to isolate the term that contains x. So when we divide both sides by 7.4, you can use your calculators to do this. The left-hand side simplifies to be 1.3514. And the right-hand side is equal to 1.12 raised to the power of x over 2. Note that both sides of these equations cannot be represented with the same base. So we have to take the log of both sides. So we have the log of 1.3514 equals the log of 1.12 raised to the power of x over 2. Now we can use the power law of logarithms and bring that exponent in front of the log of 1.12. So then we can divide both sides of the equation by the log of 1.12. And the left-hand side then simplifies to equal 2.6572 is approximately equal to x over 2. Cross-multiplying, we get the value of x to approximately equal 5.3 years. So this solution means that it will take approximately 5.53 years for the population of 7.4 million seals to reach 10 million seals. Let's look at another example. In example 2, we have strontium-90 has a half-life of 25 years. How many years will it take a sample of 50 milligrams to decay to 20 milligrams? So once again, we will set up an exponential equation where we have y equals a multiplied by c to the power of x over b. We know that the initial value of strontium-90 is given to be a equals 50 milligrams. The value of c here will equal 1/2 because we are dealing with the half-life of a substance. And the value of b here is equal to 25 years because we are told that strontium-90 has a half-life of 25 years. So now we can set up the equation so that we have y equals 50 milligrams multiplied by 1/2 raised to the power of x over 25. Let's look at what the question is asking us to find. It's asking how many years. So once again, x represents the time. So we are asked to find x when 50 milligrams decays to 20 milligrams. So that would be when y is equal to 20. Substituting this value for y into the equation, we have 20 is equal to 50 multiplied by 1/2 raised to the power of x over 25. Similarly, to solve for x, we will divide both sides of the equation by 50. So then the left-hand side of the equation equals decimal 4 will equal 1/2 raised to the power of x over 25. Once again, both sides of the equation cannot be represented with the same base, so we need to take the log of both sides of the equation before we begin to use the property of logarithms. Now we can use the power law of logarithms again, and we can move the exponent x over 25 in front of the log of 1/2. So then we can divide both sides of the equation by the log of 1/2. And the left-hand side simplifies to be 1.3219 to approximately equal x over 25. Cross-multiplying, we get the value of x to approximately equal 33 years. So as a conclusion then, it takes approximately 33 years for a 50 milligram sample of strontium-90 to decay to 20 milligrams. In example 3, Rick invests $7,500 in a fund that triples in value every 7 years. Rhonda invests $15,000 in a fund that doubles in value every 8 years. To the nearest tenth of a year, how long will it take for them to have the same amount of money? So if we look at Rick's situation and we try to set up an exponential equation of the form y equals a times c raised to the power of x over b, we will have a to equal $7,500. This case, we will have c to equal 3 because of the word triples, and the value of b will equal 7 years. So for Rick's situation, his equation can be represented by y equals 7,500 multiplied by 3 raised to the power of x over 7. Similarly, we can find an equation that represents Rhonda's situation. So it will be of the form y equals a times c to the power of x over b, where a is equal to $15,000. The value of c is equal to 2, because we are told that the $15,000 doubles in value every 8 years. So the value of b will equal 8. So an exponential equation to represent Rhonda's investment will be y equals 15,000 multiplied by 2 raised to the power of x over 8. So the question is asking, to the nearest tenth of a year, so that's one place after the decimal, how long will it take for them to have the same amount of money? So once again, we are going to let these y values, let the two equations equal each other, which will give them the same amount of money. And when we determine the value of x, that will give us the time required for that to happen. So we have $7,500 multiplied by 3 raised to the power of x over 7 is going to equal 15,000 multiplied by 2 raised to the power of x over 8. Simplifying this equation, we will begin by dividing both sides of the equation by 7,500. On the left-hand side, we are left with 3 raised to the power of x over 7. And on the right-hand side, 15,000 divided by 7,500 is just equal to 2, multiplied by 2 to the power of x over 8. I'd like for you to notice that on the right-hand side of this equation, you are multiplying powers with the same base. So using a rule for exponential equations, when you multiply powers with the same base, you can add your exponents. So 2 is the same as 2 to the 1. So here we have 3 to the power of x over 7 equals 2 to the power of 1 plus x over 8. So then we can rewrite that as 3 to the x over 7 is equal to 2 to the power of x plus 8 over 8. Again, we cannot express both sides of the equation with the same base, so we need to take the log of both sides of the equation. And then we can use the laws of logarithms to find our solution. So again, we will use the power law of logarithms. So we move the exponent x over 7 multiplied by the log of 3 will equal x plus 8 over 8 multiplied by the log of 2. We can calculate the log of 3 and the log of 2 using our calculators. So we have x over 7 multiplied by decimal 4771 will approximately equal x plus 8 over 8 multiplied by decimal 3010. So now we can multiply that out. Just go up there on the other side of the screen. And x over 7 multiplied by decimal 4771 is decimal 0682 in front of x will approximately equal, that's the same as x plus 8 multiplied by decimal 3010 divided by 8 is decimal 0376. So now using your skills with algebra, you will get the right-hand side to equal decimal 3076x plus decimal 3010. So now we can bring all the terms containing x to one side of the equal sign. And that will approximately equal decimal 3010. The left-hand side, we get decimal 0306x to approximately equal decimal 3010. And once again, we will divide both sides of the equation by decimal 0306. And x is approximately equal to 9.8 years. So as a conclusion then, it will take approximately 9.8 years for Rick and Rhonda's investments to be equal. And in the final example, we have a vehicle that was purchased for $34,000, depreciates at a rate of 75% every 6 years. Another vehicle purchased for $18,000 depreciates at a rate of 50% every 4 years. Create an exponential function for each situation and algebraically determine the amount of money required for the two vehicles to be equal in value. So if we look at setting up an exponential equation to represent vehicle number 1, it will be of the form y equals a times c to the power of x over b. So we have the value of a to equal 34,000. But this is an example of an exponential decay because we're told that it depreciates at a rate of 75%. So this time the value of c will be calculated by using 1 minus the rate. That will always be the case when you're working with depreciation. So c is going to equal 1 minus 75%. So c is equal to 1 minus decimal 75, which is equal to decimal 25. The value of b would equal 6 years. So for vehicle number 1, the equation will be y equals 34,000 multiplied by decimal 25 raised to the power of x over 6. In the case of vehicle number 2, we again will set up an exponential equation of the form y equals a times c to the power of x over b. The value of a is equal to 18,000. This is again another case of depreciation. Depreciates at a rate of 50%, so we use 1 minus the rate. So c is equal to 1 minus 50%. So that's 1 minus decimal 50, which is equal to decimal 50. The value of b is equal to 4 in this case. So then this exponential equation will be y equals 18,000 multiplied by decimal 50 raised to the power of x over 4. So what we are asked to do then is to algebraically determine the time required for the two vehicles to be equal in value. So once again, we will let the two equations be equal to each other and we will solve for x. I'm going to go to a clear screen in order to answer that question so that we have enough room to do so. So we are asked to solve 34,000 multiplied by decimal 25 raised to the power of x over 6 equals 18,000 multiplied by decimal 50 raised to the power of x over 4. To begin, we will divide both sides of the equation by 34,000. So on the left-hand side, we have decimal 25 raised to the power of x over 6. And on the right-hand side, 18,000 divided by 34,000 is decimal 5294. We use 4 places after the decimal because the less rounding we do, the more accurate our answer will be. So any rounding off we'll do it at the very end of the problem. Okay, so that's multiplied by decimal 50 raised to the power of x over 4. We will begin by taking the log of both sides of the equation. This step is important because you cannot use the property of logs until you do so. You need to take the log of both sides of the equation. And note that on the right-hand side, we have the log of a product. So we're going to rewrite that as the sum of 2 logarithms. So we have the log of decimal 25 raised to the power of x over 6, and that will be equal to the log of decimal 5294 plus the log of decimal 50 raised to the power of x over 4. So in this case, we are using the product law of logarithms. And now we will use our power law and move these exponents. X over 6 will be multiplied by the log of decimal 25, and that will equal the log of decimal 5294 plus x over 4 multiplied by the log of decimal 50. We can use our calculators to evaluate these logarithms. So we have x over 6 multiplied by a negative decimal 6021 will approximately equal the log of decimal 5294 is approximately decimal 2762 plus x over 4 multiplied by the log of decimal 5 is a negative decimal 3010. So then the left-hand side simplifies to be a negative decimal 1003 in front of x to approximately equal negative decimal 2762, and x over 4 times a negative decimal 3010 is a negative decimal 0753 in front of x. Bringing our like terms together, we have negative decimal 1003x plus decimal 0753x will approximately equal a negative decimal 2762. So then we have negative decimal 025x to approximately equal negative decimal 2762. We divide both sides of our equation by negative decimal 025, and the final value of x then is approximately equal to 11 years. So that solution means then that it takes approximately 11 years for the two vehicles to be equal in value. Just a few tips then on or key ideas as a summary of what we do when we solve these real-world situations. So many real-world situations can be modeled using exponential or logarithmic equations. Some useful tips on solving these equations are listed below. I recommend that you read through the question carefully to understand what the question is asking. Then we can use the given information to set up an exponential equation in the form of y equals a times c raised to the power of x over b. Simplify both sides of the equation as much as possible. First, you could express each side of the equation with the same base if possible. If not, then you have to take the logarithm of both sides of the equation. And then you use the laws of logarithms to solve for the indicated variable. Reject any extraneous roots or any solutions that are not permitted in the context of the question. And then state a conclusion as your final answer. Always make sure that you have answered the question that was being asked. Thank you for your time and your attention, and we will do some more applications of these logarithmic equations in the next presentation as well. Thank you.